Hi everyone, this is Rebecca, and today we'll be going over the CS 88 midterm question for spring 2022, question 5, aggregate. All right. First, before I go over the problem, I just wanted to go over like my general advice and like strategy for coding problems. So the first thing that I'd recommend doing is to read the problem and try to understand as much of it as possible, obviously, when you're reading it. And then you might also want to annotate the problem, like underline things, circle things that you find important, things like the return type or the type of the parameter. Whether the function mutates or returns something, or perhaps both. The third thing is to look at the doc tests and make sure that you understand like the input output and what the function or what your expected output is going to be. Then you may or may not want to kind of pseudocode or like look at the skeleton for any hints on how you might implement it or like the algorithm that you should use. The fifth thing you should do is code. And then the sixth thing you should do is kind of like test it out. Obviously, you don't have a Python interpreter, or like you can't really run your code because this is a pencil and paper test, but you can still kind of go through it, maybe like draw a really like quick sketch or like environment diagram just to kind of prove to yourself that your function works. Of course, part 6 is kind of more of a step that you should do if you feel comfortable and if you like have time to do that. But yeah, otherwise, of course, always try to put something down because there's always partial credit and you never know, you might get it right. All right, so let's do the first step and read the problem. All right, so it says complete the aggregate function, which aggregates certain digits of n from right to left using the 2-argument function func. Aggregate only aggregates a digit d if cond d evaluates to true and d is not consecutively repeated. For example, if you have n is equal to 222 and the digit 2 satisfies cond, you will only aggregate using one of the 3 consecutive 2's. Finally, the first time func is called on a digit of n, pass base as one of the arguments. Note that the order in which arguments are passed to func does not matter, i.e. func xy equals func yx. Okay, cool. So as you can see, as I was reading through this, I kind of like underlined the parts that were kind of important. Something else that I like to do generally also is to kind of annotate the method header. So here I can say like aggregate returns like an integer, and then n is also an integer. Func is a function that takes in 2 arguments. Cond is a function that returns a Boolean, and base is also an integer. It's like your starting value. Okay, all right, now let's take a look at the doc test and make sure we kind of understand what this problem is saying. So here we import the add and mul functions, which do exactly what you would expect. They add 2 numbers or multiply to 2 numbers. We have this lambda function called add times 3, which takes in 2 numbers and adds them together and then multiplies them by 3. We have an is_even function, which returns true if x is even. And finally, we have like the actual meat of the problem where we call aggregate on 1, 2, 2. Add times 3 is even and 0. So you can also kind of see here that the doc tests are helpful in a sense that they provide comments explaining like why we return 6. So in this case, right, we have this is_even function, which is what we check first for each digit of n from the right to the left. And we see that indeed the first digit here is even, right? So we do want to process it, assuming that there's no like consecutive integer. So we can kind of see that there's 2 consecutive 2's. So we only want to aggregate one of them, right? It doesn't really matter which one at this point in the problem, but as we'll see later in the code, you can actually, the order kind of does matter, but we'll talk about that in a second. So Here we only process one of them. Let's say I process the second one, right? And what we want to do is we want to call add times 3 on the base and the current digit, right? Because this is the first digit that we process, right? Based on what this like phrase was saying. So we add 0 plus 2 and we multiply it by 3, which becomes 6, right? And then we move on to the next digit, which is 1. But this time 1 is not even, right? So we don't process that. And then we move on to the next digit, but there's nothing left, so we just return 6. Okay. All right, what about this doc test? So here we see we start out with 2, which is indeed even. So we add 2 with the base, which is 0, which you can kind of see over here. Then we move on to the digit 1. 1 is not even, so we don't add anything and move on. Next, we see this 2 here, and 2 is indeed even. There's no like consecutive repeat of 2, so we add that to the result. And then next, and finally, we have this 4 here, which again is even. There's no consecutive 4s, so we add 4 to the result. So we return 0 plus 2 plus 2 plus 4, which is 8. Okay. Third doc test here, we have aggregate is called on 2, 2, 2. And once again, we're adding them together and checking if they're even, but this time notice that the base is 1, right? So how does this change things? Well, we see here that we have these consecutive 2s, right? So we can kind of say like, let's skip this one and skip this one and instead just aggregate this one, right? And in this case, there's nothing that's consecutive to after it, right? So we can then add this to the base, which is 1, because 2 is even, right? And so the result is 1 plus 2, which is 3. Right. You may also be wondering at this point, like, why do we skip the first 2 2s and we do the third 2 instead? And once again, like I mentioned before, I'll explain that once we get to the actual code. But obviously, when you're doing this in the test, you might first think that we should do like this first 2 and then skip the other 2, but it turns out that it's kind of more difficult to do it that way. Okay. And then for the third doc test over here, we have n is 1, 1, 1. We're multiplying this time, and the base is 2. So once again, we kind of like skip the consecutive 1s, and we only operate on one of them, which we choose to be the leftmost one. And none of them are actually, sorry, let's backtrack a little. So none of them actually are even. So we skip all of these. And so the result is just going to be the base by itself, which is 2. Okay. All right, so now that we've gone through the doc test and kind of understand the problem more, let's look at the skeleton code that they provide here. So, all right, so we can see that we have this result variable, which we can kind of guess will store the thing that we return. And indeed, we do return result at the bottom here. So result somewhere inside of this while loop is probably going to be updated. But remember that we only want to update it, right, if the condition that is true for that particular digit and there's no like consecutive digits for like the last one. For example, here where we have 2, 2, 2, there's like 3 consecutive 2s, but we only want to process one of them. Okay, so we know that we have to like update result if cond digit is true and digit not consecutive. Okay, and we can kind of see from the skeleton code too that this if statement here seems to fit this really well. In fact, there's like 2 different conditions. So we're probably going to do this inside of the if statement, and this is probably going to update result, right? Or it's probably where we update result. Okay, then we have this while loop, and we have to determine when we want to stop, right? So before we kind of jump into the while loop and what to put here and here, it might be useful to kind of review how you may have learned how to manipulate digits or get like the last digit from a number in like homework or lab or in projects. So you may recall that if we have some number n, right, in order to get the last digit of it, as in like the rightmost digit, we mod it with 10. And to kind of cut off that last digit, we floor divide it by 10. So to give an example, right, if we have the number 13 is n, right, 13 mod 10 is equal to 3. And you can see that that is indeed the rightmost digit. And in order to kind of like cut off the last digit, since we have kind of gotten its value already through the modulus, we floor divide it by 10. And so this would give us 1, which indeed kind of takes out the 3, right? Okay. So how do we know when to stop, right? Like when we're processing these digits from right to left, as the problem states up here, we want to stop once we have no more digits in order to process, right? When does that happen? Well, let's take a look at an example of just like 222, which they give us, right? We know that inside of the loop, we're going to be updating n so that it gets floor divided each time. So if we were to floor divide the first time, the number would become 222, right? And then if we floor divide again, it becomes 2. And then if we floor divide again, it becomes 0, right? And you'll see that if you try this with other examples, that once n hits 0, that's basically when we've run out of digits to process. So we can kind of fill in this while loop condition with while n is greater than 0, right? Because once n is equal to 0, then we know we have stopped. And what this means in like English terms or like conceptually is we have run out, or while we still have digits, I should say. So while we still have digits. Okay. And then inside of the while loop, right, we want to extract the digit, which we can use with the modulus 10 operation that we talked about. So n mod 10. And then we want to update n so that we cut off the digit that we just processed. So n becomes n floor divide 10. Okay. And then in the if statement, as we were talking about before over here, we want to check if the condition is true on the digit that we're processing currently. So we call cond on digit. And on top of that, we want to check if the digit is like a consecutive one, such as the example of 222, right? So I mentioned earlier that like one way that we could possibly think about doing this is we have some sort of like variable maybe that keeps track of the previous digit, and then we check if the current digit is equal to the previous, right? Because if that's the case, then it's consecutive. But unfortunately, in the skeleton code, there isn't like a line for us to declare another variable in order to hold the previous value. So how can we check then whether something is consecutive? Well, if we're going back to the 222 example, so let me do this in another color maybe. Okay, so going back to the 222 example, remember that the problem says we only aggregate using one of the 3 consecutive twos, or the 3 consecutive like whatever digit is repeated. So it doesn't restrict us and say like, oh, we have to process the rightmost one. We could process the middle one, we could process the left one, whichever makes the most sense for the skeleton code and for the problem, right? So like I mentioned before, we can't really store a previous value. So maybe what we can do, right, is let's say we're currently processing this middle one. How do we know that it's consecutive? Well, we can look at the next, or sorry, let's look at this rightmost one, right? How do we know that it's consecutive? Well, we can look at the next digit to the left of it. And if that digit is equal to the current digit, then we know that there's like a repetition, right? So if this is n, right? And if this is digit, which is n mod 10, right? And at this point, right, we set digit to be n mod 10, but then we also update n so that it's chopped off. So now n is actually really, now n is 2, 2, right? And just imagine that there was this 2 that we processed earlier. So if we then do n mod 10 again, we can get the digit that's to the left of the one that we're currently processing, which is this one, right? So what we can put in this second condition in the if statement is if cond of digit is true and digit is not equal to n mod 10. Okay, and that basically checks if we see any consecutive digits. And you might be wondering, like, why does this work? Well, basically, this will, for the example of 222, right? When we're processing this rightmost one, we know that it's consecutive because the one on the left is also 2, right? So we skip this one, right? Because the if statement condition is false. And then now we're processing this 2. We again look to the left side and we see that once again, there's a repeated digit. So we skip this one. And then now we see this final 2 on the leftmost side. We see on the left of it, there isn't like any repeated digit. And so we will process this one. So in other words, like every time we see a consecutive digit, it's just going to process the leftmost one, but it doesn't really matter because all of the digits are the same anyway, right? All right. And then finally, inside of the if statement, we have to update our result variable. So what do we want to update it to though? So you might have remembered from the doc test that we kind of do the operation that was passed into func on whatever the previous result was, right? Because we're kind of accumulating the values. Like here, for example, our first result is 0, which is the base, right? And then we add 2 to the previous result, and this becomes our current result. Then we add 2 again to the previous result, and then finally we add 4 to the previous result. And so in code, what that looks like is we're saying that result is updated so that it is the result of calling func on result and the current digit that we're looking at. Okay, and as the problem states too, you could have also written this as func digit results. It doesn't really matter, either way is correct and acceptable. All right, cool. And so yeah, you would have put this in here. So just, I guess, to write this in like a cleaner fashion, I'll just rewrite it again. So while n is greater than 0, we take the digit, the rightmost digit, we chop off the rightmost digit, we check if cond of digit is true, and that there's no like consecutive digits that we're processing. We update result. And now we're done with aggregate.